Okay. And we'll first talk about what converse even means. It's not a shoe. So, if you have, so I have on here, what does converse actually mean? I need it quiet, please. So if you have this this statement, this equation, if 6 plus 5 equals 11, the converse of that would just be flipping it around. So then you could say that 11 equals 6 plus 5. Okay, that's the converse, is just switching it around. So then converse of the Pythagorean theorem, normally we say if you have a right triangle, then a squared plus b squared equals c squared. So the converse is if a squared plus b squared equals c squared, then you have a right triangle. So the converse would be used to identify that you have a right triangle versus yesterday we were given that we had a right triangle and we had to find something that was missing. So it's kind of being given the opposite information and then the opposite outcome. And then C, remember, it has to be, we talked about C has to be the hypotenuse, but that is the longest side. For a right triangle, C is the hypotenuse, which is the longest side. Hypotenuse also, only right triangles have a hypotenuse. You only refer to the hypotenuse of a right triangle. For any other triangle, you're just talking about the longest side, but it's not called a hypotenuse unless it's right. So part of using the converse is identifying what type of triangle that you have, and you can use the sides to classify triangles as acute, obtuse, or right. We talked about how a right triangle has a 90-degree angle, a right angle. An acute triangle would have all angles that are less than 90. And then an obtuse triangle has one angle that is greater than 90. But you can identify what type of triangle you have by finding the relationship between the sides. So if you have 3 sides, I'm going to fill this in right away. This is going to be the same for all of them. C for all of these is the longest side. So for C being the longest side, if C squared is equal to A squared plus B squared, then you have a right triangle. That's the Pythagorean theorem, the converse of it. If C is your longest side, and C squared is, this is the less than symbol. I'm going to show you this because when you see these symbols, you need to know if I give you like less than or greater than which is which. If you make the symbols on your hands, this might seem really silly, but could be helpful. If you make the symbols on your hands, less than is on your left hand. Less than's on the left, so greater than's on the right. So less than's on the left. So this is the less than symbol. C squared is less than A squared plus B squared. So that would mean you have an acute triangle. And then if C, again, is your longest side, but C squared is greater than A squared plus B squared, then that means you have an obtuse triangle. There would be an obtuse angle in there. There's diagrams to go along with all of these. So that's what we're going to do for those first 4 examples, is classify each triangle as acute, right, or obtuse. And for these, thinking ahead to when you have a quiz on this, what I'm looking for, I don't want you to just write by this, right, obtuse, acute, right, whatever it is. Because I don't know then, are you guessing or did you actually do math to figure it out? I need to see that you're showing some sort of work to justify your answer. And I'll show you the work that I expect you to show. So what you first want to do is identify from your 3 sides, these are 3 sides of a triangle, identify which one is your longest so you know which one C is. So I know for 7, 16, and 14, 16 is the longest, so 16 is going to be my C. It doesn't matter if 7 is A or B or if 14 is A or B, but you need to know which one is your longest. So I'm going to set this up kind of like these, but I don't know which symbol is going to be in between. I don't know if they're going to be equal, less than, or greater than. So I'm going to find what 16 squared is, my c squared, and then I'm also going to calculate what is 7 squared plus 14 squared. So what is the sum of the other two sides squared equal to? So then I would calculate 16 squared, that is 256. And then if I type in 7 squared plus 14 squared, that is 245. Okay, then you compare these two numbers. 256 is bigger than 245. So if that's the case, then I look up here, then I have an obtuse triangle. Okay, questions on that? That's the work I'm looking for. I don't just want to see obtuse written there. I want to see how you came up with it being an obtuse triangle. That's how you're going to get full credit for that type of question. So why don't you answer number 2? We're going to go through the ones that have the square roots together. So I want you to quickly answer number 2. Figure out what type of triangle that would be. If you're done reading, you could start trying the next ones. I know the ones with the square roots might be a little more challenging. All right, I think I know I didn't walk over there, so I apologize. If you have a question, though, let me know. You should have come up with this is a right triangle. All right, so 41 is your longest side. 41 squared is equal to 40 squared plus 9 squared. They're both 1,681. Are there any questions on that one? I know I didn't get to that side of the room, but there was a lot of talking, so I figured we were done and just waiting. Okay, so then for 3 and 4, so these ones are a little different because of the square roots. Not different in the sense that you follow the same steps, but you first have to identify for number 3 which one of these is your longest side. Now, what you can do then is you are going to keep them as square roots, but you can find the decimal approximations just to figure out which one is the longest. So like if I type in the square root of 5, that's about 2.2. So I'm just going to write next to this, it's about 2.2. All right, square root of 12 is about 3.5. 5 and square root of 13 is about 3.6. Okay, so yes, you might have said, well, between the square root of 5, 12, and 13, the square root of 13 is probably the largest. I would type them in just to make sure, especially when you have something like number 4, it might be a little more difficult to tell which one is the largest when they're being multiplied then by something. So the square root of 13, that would be my C. That's the longest. So I would then do square root of 13, keep it as the square root of 13 squared. And then I also have to figure out what is the square root of 5 squared plus the square root of 12 squared. And then I would compare. If you want to, for the time being, like in this step, to put a question mark in between, because you don't know, are they equal, which one is greater or less than, just so you have some sort of symbol separating those. What happens when you square a square root? Yeah, I'm hearing some different things. Claire, can you say what you said? Yes, and I think, Hannah, that's what you said. They kind of cancel each other out, and you're just left with a number that's in there. These are inverses, like addition and subtraction. They cancel out. So this is just 13. This would just be 5 plus 12. So I'm comparing 13 to 5 plus 12, which is 17. Okay, so 13 is less than 17, meaning I have an acute triangle. Questions on that one? Okay. 4 then, a little bit different yet because of the numbers multiplied in front of the square root. So again, figure out which one is the longest. So if I type in 2 square root 3, or 2 times the square root of 3, that's about 3.5. 4 times the square root of 4 is 8. And 3 times the square root of 5 is about 6.7. All right, so this one you might have looked at and said, well, the one with the square root of 5 must be the largest. It's not, though. 4 square root 4 is the largest. And then because this is exactly 8, because keep in mind, square root of 4 is 2. This is just 4 times 2. If you would like to, I can just write for the, I'm going to put C here so you know what C. I'm just going to write 8 squared. Okay, I don't have to put the 4 square root 4 squared because it is exactly 8. I didn't round it. That is the number 8. The other two, I want to leave the square roots because I rounded those. So then I'm comparing it to 2 square root 3 squared plus 3 square root 5 squared. And again, I'll put a question mark here. I don't know how they're going to compare. So 8 squared is 64. And now what happens with these, you certainly can type this in your calculator, but I also want to show you how to think through this. This means the square is going to the 2 and to the square root of 3. So I have 2 squared, which is 4 times. When I square the square root of 3, those cancel to just give me 3. So this whole thing is 4 times 3, which is 12. Okay, however, like I said, I could type that in my calculator. I could do parentheses 2 square root 3. I need to close the parenthesis for the square root and then the other parenthesis that I had in front here and then do squared. And it's going to give me 12. So you can type it in your calculator. I'm not saying you can't do that. And that means this one here, if I distribute that square, 3 squared is 9 times the square root of 5 squared is just 5. So that's going to be 45. So I have 64, and then I'm comparing that to 12 plus 45, which is 57. 64 is larger, so my triangle is obtuse. Any questions there? Okay. What I'm going to do, so I want you to flip to the back. And now these are just some additional examples practicing with Pythagorean Theorem. So what I'd like to do, just to leave you some time because we're done at 11:17. Number 5, you had problems like this even on your homework from last night. 6 is a similar problem to what we just did. It's asking, is the triangle a right triangle? So you would be using the 3 sides to prove it's right or not. I would like to go through number 7. Okay, I want to leave you time to work on your assignment, but I want to go through 7 because we haven't gone through an example like number 7. So 7 says find the value of x, and you have your right triangle written there. So just as a reminder for what I said yesterday, because here we have 2 different sides that have x in it, figure out which one is the hypotenuse. So that would be opposite the 90-degree angle. Just x is the hypotenuse. Okay, so if you're thinking of the formula a squared plus b squared equals c squared, x is my c, and then it doesn't matter which one of these I call a and b. So I'm just showing this because I did have some of you were just setting everything equal to x squared. I want to make sure you're not always doing that. So when I put this into the formula, especially with the x minus 3, this is a quantity. You need to have parentheses around it. So I would have the quantity in parentheses x minus 3 squared plus 9 squared equals x squared. And now, when you have addition or subtraction in parentheses with an exponent like this, I cannot distribute the exponent. Okay, I could distribute it here because these 2 numbers would be multiplied together. So you can distribute an exponent if what's inside is being multiplied, not if it's being subtracted. What this means x minus 3 times itself. Okay, and then I'm going to write plus, I still have the 9 squared, I'm going to write 81 for that right away, equals x squared. What do I have to use to multiply these? This is reviewing from algebra. FOIL, yes. FOIL, first, outer, inner, last. So I multiply my first terms, x times x is x squared. X times, this is outer, x times a minus 3 is minus 3x. Now I do the inside. Negative 3 times x is another minus 3x. And then a minus 3 times a minus 3 is a positive 9. And then I still have the plus 81 equals x squared. So when you see a quantity squared like that with addition or subtraction, you do have to FOIL to simplify that. And I have some simplifying I have to do on this side. I can combine the x's. These do not cancel out. Negative 3x minus 3x is a negative 6x. So I have x squared minus 6x. I can also combine 9 and 81, so plus 90 equals x squared. And then I have to solve this for x. So now also notice I have x squared on both sides. I can subtract x squared from both sides, and they both end up canceling out. So I still have negative 6x plus 90 equals, I have nothing over here, so that's 0. And now to solve for x, I'd want to get, well, I need one of these on the other side. I'm going to So I have, I'm going to continue this over here, negative 6x equals negative 90. And then I would have to divide by negative 6. And x would equal a positive 15. Okay, so reviewing some algebra with that one. Questions on that? Okay, and then 8, I am also going to hold off on example 8. I really want to leave you time to work. We have about 10 minutes left right now as it is. So